So welcome everybody to this latest A-level video on 162 Maths, and in this video we'll be continuing with partial fractions and we'll be focusing on where you've got repeated root or power in the denominator. So this is when in the denominator the expression when factorised has one bracket or the linear function is a repeated root or has a power. Now the degree of x in the numerator is still smaller than the one in the denominator, which again is really an important check that you do. So here's an example of what we're going to be dealing with. So here we've got our degree of x is equal to 2 and the degree of x of the denominator is 3. So this is what we would class as a proper fraction or a proper algebraic fraction. Now the key thing to note is in this that one of the brackets is a repeated root or has a power, which is here. So this is what we class as a repeated root and stroke has a power. Now more often than not the power will always be 2 because obviously it doesn't go into, at this particular level, it doesn't go beyond, let's say, cubics in your denominator. So do not worry if you get obviously a cubic or like so, because like I said, I will show you an example of where that is the case. So let's have a look at what happens. So when splitting an algebraic fraction with a repeated root or with a power in the bracket, it may be very tempting to write it like this. So here, like we did with 3 linear functions in the denominator, you write your a, b, c, and then each one has a bracket. Now because we have in this we have 2x minus 1 squared, you might think to yourself, okay, so one has 2x minus 1, another one has 2x minus 1. Now this, although it may seem logical, is actually incorrect. Now the reason for this is because when you go through the process of multiplying the both sides by the denominator of the original algebraic fraction, that b and c will generally give you the same value, and this is where that might not be the case. So doing this method, b and c will always be the same. Now instead, to prevent that and to try and get that accurate, because obviously in reality that's may not always be the case, so in reality what we need to do is instead we write this as a over the first bracket or one of the brackets. Now for the repeated root we write 1 without the power and then we write 1 with the power. Now you might think to yourself, well hang on a second, if I'm multiplying these 3 denominators together, surely I'm going to increase the degree of x by 1. Well actually you're not, because you think to yourself, we want a common denominator. This one's just got 2, so our common denominator here would actually be 2x minus 1, 2x minus 1 squared. So this is how we need to be writing it. So in other words, what we need to do is for the repeated root, have one fraction without a power and one with the power. And there we go. So again, although it may seem a little bit uncomfortable to do that, it will still come into fruition. So the key thing, the different addition then, is to make sure you write 1 with a single power and 1 with the actual original power. Now there's no set method. I'm not going to bore you with the method because if you've watched the previous 2 videos it's going to be generally the same. So from this, what we then need to do is, just like before, we multiply both sides by the original denominator. So here we had, if I just write, we had a over x minus 1. And what I'm going to do is I'm going to multiply that by x minus 1, 2x minus 1 squared, plus b over 1 of the repeated root without the power. And I'm going to multiply that by x minus 1, 2x minus 1 squared. And then I've got c over 2x minus 1 squared. And that's going to be multiplied by the original denominator, which was x minus 1, 2x minus 1 squared. And that then disappears. Now from this I can then simplify this. So by simplifying, that cancels with that, this cancels with one of those, and all of this cancels with all of that. So what I'm left with is going to be, let's use a different colour, I'm left with 12x squared minus 13x plus 2 is equal to a, and I've got 2x minus 1 squared plus b, and I've got x minus 1 2x minus 1 plus c, and that's just going to have x minus 1. Now from this, what I can then do is go on to work these out. So what I then need to do is find the values, substitute values of that make the brackets equal to 0. So for this, I need to make x equal to, it's going to be a half. For this bracket, I need to make x equal to 1. This one again is going to be x equals a half, and there we go. So we've got 2 possible values. So if I substitute those values in, so when x equals 1, so we do that one first, we've got 12 minus 13 plus 2 equals, and that means anything that's got a x minus 1 is going to disappear, so that's going to give me the value of a, and that's going to be a lots of 2 times 1, which is 2, take away 1, which is 1, and that gives me a value of a equals 1. And then if I then substitute x equals a half, then what I'm going to end up with is 12 a half squared minus 13 times a half plus 2 equals, and anything that has got a 2x minus 1 is going to disappear, so I'm going to end up with c, and that's going to be minus a half there. So that then gives me a value of c equals 3. Now the problem with this is, unlike when we had 3 linear functions, is that any other values is I can't make the other bracket equal to 0, because obviously there is a shared bracket here. So in order to find b, that uses both these 2 values, so ultimately the b is just going to disappear. So what I need to do instead is I need to pick a third, a relatively small value. So I need to make up a value of x for me to substitute in. Now because I know the values of 2 of the numerators, so in this case I know the values of a and c, then that's going to be absolutely fine. However, I need to pick just a random value of x, relatively something small, something positive. Personally, I would always go for x equals 0, but you definitely want to stay away from using any values that you've already substituted for x. So in this case, I'm not going to use x equals 1, and I'm not going to use x equals a half. So what I'm going to do is I'm going to let x equal 0. Now with x equals 0, what we'll end up with is 12 0 squared minus 13 times 0 plus 2 equals, and then I'm going to end up with it was, let me just quickly remind myself, got a, and that's going to be 2 lots of 0 minus 1 and squared plus b lots of 0 minus 1, 2 times 0 minus 1, oh, up in there, 0 squared plus c lots of 0 minus 1. And just double check to make sure that's correct. That all looks absolutely fine. So then simplifying all of this, I get 2 equals, and then I've got 2 times 0, which is 0. Take minus 1 from minus 1 squared, just going to give me a, plus this is going to give me minus 1, that's going to give me positive 1, and so that's going to give me minus b, and this is going to give me minus c. So I've got a minus b minus c. Now from this I know that a equals 1 and c equals 3. So substituting those numbers in, I get 2 equals 1 minus b minus 3. And if I take all of those numbers to the other side, so I take away 1 and plus 3, then that gives me a value of b equals 4. So from this, I've now got my 3 values, and so all I then need to do is write down that as my final answer. So looking at my original question, which I had 12x squared minus 13x plus 2 over x minus 1, and then 2x minus 1 squared is going to be equal to 1 over x minus 1 plus 4 over 2x minus 1 plus 3 over, and it's going to be 2x minus 1 squared, and there is my final answer. And again, just like before, I strongly recommend that you don't just leave your answers A, B, C. Always finish off by substituting those numerators into the original question and then writing it as your partial fraction form. Do you have to write the original question, the original algebraic fraction? Probably not, but definitely it looks better if you do. So let's have a look at these examples. Now again, these are slightly different, but the same thing kind of applies. So looking at this, we want to write, the question asks us to write as partial fractions. So for this, I'm going to write it as a over, now I've just got one repeated root, and it's not a problem. So I'm going to write 1 without a power and 1 with the original power, like so. Then if we multiply out the denominator, so I end up with x equals, and then I've got a over. Now if you're ever never too sure what cancels out, then just write it out, just like I'm doing here. So we've got b over x minus 2 squared times x minus 2 squared. Then from this, what cancels out? Well, that's going to cancel out with one of those, and all of that's going to cancel with that. So what I'm left with is x equals a of x minus 2 plus b, and there we go. Now from this, I'm going to let x equal 2. When x equals 2, I end up with 2 equals, that's going to the a x minus 2 is going to disappear, I'm left with b, so b equals 2. Now for a, what I'm doing is just pick another value, random value, so I'm going to let x equal 0, just relatively quite small, so I end up with a 0 equals a, and 0 minus 2 plus b, so I end up with 0 equals minus 2a plus b. Well, I know that b equals 2, so I end up with 0 equals minus 2a plus 2. Take the 2 over, so I've got 2 minus 2 equals minus 2a, so a equals 1. So then writing, once I've got those two variables, I can then finish off by substituting those into these values here. So I've got x over x minus 2 squared equals, and what's going to be equivalent to. Again, you wouldn't lose marks if you didn't write it as an identity, but we've got 1 over x minus 2 plus 2 over x minus 2 squared, and there is my final answer. So then moving on to our next example, or I should say our last example, we've got this here. So again, we're going to go through the same sort of notions. Let's get different colours. So I've got a over x plus 4 plus b over x minus 1, again without the power, and then c is the one that has got a power. Now again, it doesn't really matter if the orientation is different, so if it was written as x minus 1 squared x plus 4, then what I'd do is I'd write a over x minus 1 plus b over x minus 1 squared and c over x plus 4, but the orientation doesn't really matter because when you're multiplying, the order does not matter. So let me just get rid of this. So then from this, what we then get is multiplying out the denominator. So I get 6x plus 10 is equal to, and again, a with the other denominator, so it's x minus 1 squared plus b with, and it's going to be with both the denominators, so x plus 4, x minus 1 plus c, and that's going to have x plus 4. And there we go. So from this, I need to find out what values I need to use. Well, x is going to be equal to 1 there, and x is going to be equal to minus 4. So when x equals 1, then what I end up with is 1 minus 6 plus 10 equals, and it's going to be c that I keep, so it's going to be c 5. So I've got 5 equals 5c, so c equals. And then if I let x equal minus 4, then what I end up with is plus 16 plus 24 plus 10 equals, and this time I'm going to keep my a, and that's a is going to be minus 4 minus 1, which is minus 5. 5 squared is going to give you 25. And I've got 50 equals 25a, so a equals 2. And then for the third one, again, I just need to pick a relatively small value. I always tend to go for 0 just because it makes substitution so much easier. So what I end up with is 10 equals, and it's going to be a I substitute 1, it's going to give me 0, it's going to give me 1 plus b, and then the first bracket's going to be 4, second bracket's going to be minus 1 plus c, and that's going to give me positive 4. So simplifying all of that, what I end up with is 10 equals, and again what I need to do is remember that a equals 2 and b equals c equals and it's going to be we get 1. So from this what I then get is we've got 10, and then substituting this we've got a plus, or should I say minus 4b plus 4c, and then substitute those numbers in, I get 10 equals 2 minus 4b plus 4, and then taking those numbers all to the other side, so I've got 8, and then take away 4, so I've got 4 equals minus 4b, so b equals minus 1. And then all I then need to do is write down my final answer, so let's just write the final answer here, which is x squared minus 6x plus 10 over x plus 4 x minus 1 squared is going to be equal to a, which is 2, and then x plus 4, b, which is minus 1 over x minus 1, and plus 1 over x minus 1 squared. And there you go. And there is our final answer.